Awesome. Fraction Frenzy, Saturday Math. Here we go. We've got people, obviously, always lots from Ohio. I am from Ohio. I live just east of Columbus. So many of the clients that I have, many of the school districts I serve, many of the teachers I coach are right here in Ohio. And then I venture outside of Ohio momentarily throughout the year. And let's see where we've got. We've got our good friend Teresa from Massachusetts. And we've got our amazing friend Kirk from Atlanta, Georgia. My son just bowled in Atlanta last weekend. He goes to Weber International University in Florida. It's about an hour south of Orlando. He's on their bowling team. He actually went to the university for bowling. And there are two JV bowling teams, and they both got first and second place at the tournament in Atlanta last weekend. So super cool for them. We have a couple new people. Welcome so much if you are new. So much welcome. And we have a new from Granville. Typically, when we hold these sessions in person, we hold them at the College Townhouse in Granville, which is right beside the Granville Inn, right across the street from the Buxton Inn. And a few of our Saturdays in the spring are going to be back in person. So all my Ohio peeps out there, we're going to be back at the townhouse and we'll be able to connect in person. But don't worry, we're going to stream it live to you. So look for that coming this spring. Hang with us all year. I got my partner in crime, Sherry from Pennsylvania. And awesome, Nicole is here this morning already meeting Linda. Linda is, there we go. Yeah, Linda's from Dayton. Fantastic. Awesome. You guys are amazing. We just had a few more join. If you just joined, I am John-Elise Zupanzik, Jay-Z here in the house. Saturday morning math, and we're going to focus on fraction this morning. I am calling it Fraction Frenzy. So let's jump right in. There are actually three pitfalls, three fails to our instruction that are causing the math deficits for students for fraction. Fraction oftentimes is not innate and intuitive. I want to go back to one of the things that we always focus on Saturday math, which is number sense. Number sense, and I always have to define it because I want us to know this verbatim. I want us to be very skilled at articulating what number sense is and is not. So I say these same words all the time. And if you're new here this Saturday, don't worry. These are all one and dones. These are all standalone sessions. They're just random topics. They're not sequential. So you haven't missed anything before. So no worries at all. If you are a regular, if you're a follower, if you have interacted with us hundreds of times, also don't worry, there's always something new for you. What's really cool about the consistent followers is that you know most of what I say. But every time we interact, I attempt to put a new twist on what we already know. And that is really true facilitation of instruction and learning. And I want us to think about that as we teach throughout our year, as we teach from August through the spring. I chunk my instruction into 5 seasons. The first season is August, September. And that's when we drip out all of our content. And I'm going to show you models of that today with fraction. You're going to drip out every standard you teach at an exposure level in the form of a stimulus. And I'll define all these things today. We're in season 2, which season 2 is October through December. Season 2 is a little more laid back. It's not quite as intense for me instructionally because for the teachers that I coach, they're kind of getting the groove with their textbook. We're not playing, well, we are kind of playing survival mode just in season 2 as a teacher. It's like, okay, when is Thanksgiving break? When is winter break? Like, we're kind of in that survival mode, but not necessarily with our content. We kind of fall into our textbook because it's a good safe haven. So it's like, you know what? I don't have to push to plan lessons because I can grab my book, I can grab my resources, I can grab that, task that I always like to do. So it's a little less intense content wise as far as me planning and preparing what I'm going to do. Less intense than the August, September. Then the third season is January, and January is coming up, and our December Saturday math is going to focus on how we facilitate math instruction in January. January, we call math in a month. It's where we replicate first 15 days. Because in season 2, now from October to December, we're teaching our textbook. We're kind of getting on our comfort level of instruction and teaching, but we're always referring back to what those chunks we did the first 15 days, that August, September stretch, that season 1. January is a very intense month. It is a replication of what we call the first 15 days. It's a replication of season 1, but in January, it's up-leveled. Now, the reason I describe this is because when I say to all of us today, if you're a regular and you've had a lot of interactions with us, every interaction you have with me should be a slight up level. And that's how we should be teaching our kids throughout the year. We should expose them everything in August, September, and then October through December, trickle some of those things back in. And then January, expose them everything. And then I won't talk about seasons 4 and 5 because then we're getting a little muddy, but I just need us to think differently about the delivery of the instruction. Now, I said all of that and I got a little lack of focus and down the rabbit hole with the seasons of math. I'm going to swing right back to what I was going to make the point on, number sense. See, I don't forget, y'all. Sometimes I forget. But I am going to deliver to you today in a very non-linear way, which is actually one of the fixes for lack of student achievement, is a very non-linear, chunked delivery of math content for us as instructors. And I can't help myself anymore. That's how I deliver to adults as well and to kids. And I am, by trade and by definition, a very type A linear person. But when I began to investigate all of the struggles that kids were having in mathematics, when I started teaching 24 years ago, I started to realize I had to change. The kids did not. And the way that I had to change was to be much less type A, formal, linear, sequential, structured, because that is absolutely the opposite way that kids learn and the opposite way that we learn. I was not learning to my potential because I was trying to learn in a very streamlined, linear, structured way on everything I wanted to know, because I really love learning. Don't necessarily like the way schools structure learning, but I really personally love learning. And I would try to learn in a linear way. And it was taking so long for me to get to where I needed to be in certain areas that now I start learning in chunks. Now, if you've never met me before, if you're new here today, Jay-Z's a little radical in her math teaching thinking. But we have been making huge gains in classrooms everywhere. I'm not going to bore you with all of that today, but just hang with me today. Hang with me today and force yourself to really think deeply about what we're going to be talking about today. But number sense, see, I go down the rabbit hole, but I usually come back. Number sense. Number sense is the innate, intuitive understanding of the size of numbers. The size of numbers is the magnitude. So number sense is the innate, intuitive, inborn understanding of the magnitude of numbers. Magnitude is size, how large or small numbers are. We are born, by definition, with a certain level of number sense, either strong or weak. All animals have this. Just think about predator-prey situations. If I am prey, why do I want to be in large groups of my kind? Because there's less of a chance that the predator is going to get me as an individual. See, that's a number sense. We are born with a certain level of it. Some humans stronger or weaker. Johns Hopkins University did a study that was released in 2011 talking about their research with 6-month-olds and evaluating their level of number sense, and then following these 6-month-olds to toddler and then school age years. There's a difference between number sense and math ability. I've defined number sense, but the big word wrapped around number sense is conceptual. Math ability, the big title word is procedural. Procedural, algorithmic, mimicking, step-by-step, linear. Both of these are absolutely essential. Conceptual and procedural experiences in mathematics are equally essential. But in typical traditional schools, the procedural is where kids have most of the experiences, and that is where the least amount of learning happens. So what we need to do is we need to shift that and focus less on procedural, more on conceptual. I would even say more on conceptual because believe me, you type A, control freak, linear, like step-by-step people, believe me, you can't do too much conceptual. Your habits won't let you. So I say stretch for even more conceptual, but I say that they're equally important. So speaking of that, fraction is not an innate, intuitive understanding necessarily. Because I'm not born and, I can see large groups, small groups, it's really whole number based. So when we get to fraction, students have a sense of number and parts of number. But if I start writing a fraction like those two things, 1/4 and 1/8, in their symbolic form, hands down, even students with the highest level of number sense early on are going to say 1/8 is bigger. Because what we've just done when we've put these notations here is we've moved into the procedural, which is the not born with understanding. So if I present fraction more often without the notation and symbols and the structures, if I do that more often, and then as an afterthought, like, oh, by the way, when we say, half of my sandwich got eaten by my brother, if I just verbally say that and have kids contextualize that, they have a meaning of what that is. And then once we engage them in these contextual, conceptual experiences, then we can say, oh, by the way, remember when I said half of my sandwich was eaten by my brother? Half is this symbol in mathematics. It's weird. It's weird. It's a 1 and a 2. See, it's a 1 and a 2, and then it's got this line. And then I'll say to my kids, don't really worry about that. Let's just write it like this first. 1/2. And then to really engage kids in a conceptual foundation of fraction so that they can excel with fraction, we really want to less emphasize the symbols and more emphasize the value, the quantity, the size, the magnitude, which is the foundation of number sense. So I can write 1/4 and 1/8. It took me a long time to learn how to spell 8, friends. All right. That's a side note. There are 3 things that we are unintentionally doing that don't increase students' understanding of fraction, but actually cause misconceptions. Number 1, few exposures. And I would go as far to say none by November. Okay, when we're recording this, it's November something, 9th. It's early November. And I'm not going to call you out here, but if in your classroom it is November 9th and you have not exposed some type of fraction at least 5 times, that's what's causing some of the problem. Okay. This isn't a rehab meeting. You don't have to raise your hand and say, I am Nicole and I haven't done fractions with my kids. All right. I'm just truth telling, but I'm not going to call you out. I'm not going to make you say anything about it. So the biggest mistake is few exposures and none by November. Now, sometimes this is hard because sometimes you might be, a 7th grade teacher, you might be a 9th grade algebra teacher, and you're like, John Lee, we've done fractions like every week and they don't get them. Okay. Were they symbolic? Was it notational? Is it procedural, or did you start with conceptual? So there are just some grade levels and some courses that like fractions are inevitable. However, y'all, I've seen some 9th grade Algebra 1 classrooms that it's November 9th and kids haven't seen a fraction because we're trying to teach the algebra concepts. And so we use easy whole numbers. I mean, you can justify that however you want. The bottom line is kids aren't going to get good at fraction if they don't habit fraction, meaning lots of exposures all the time. Not in a unit-based way, not in a linear way, in a chunked way. So the first issue we have is few exposures, none by November. And when I say a chunked way, this kind of leads me to the second issue, the second fail of fractions for our kids. And that is, and I've said this multiple times already this morning, teaching fraction in a linear sequential approach with progressions. Now, yes, there are some progression, linear, sequential chunks at times. But the mistake we make is making the learning of fraction linear and sequential. Because if we said, okay, what fraction should we start with? Many of us might say 1/2. Now, this is where the debate comes in. If I took a survey, which I've done in the past, and said, what's the next fraction we should start with after 1/2? There's a debate between 1/3 and 1/4. And who's right? Everybody. You see, it's chicken and egg. It's chicken and egg. We keep searching for like a program or a textbook or a method that tells me the right order. But we're seeking the wrong thing. It doesn't matter. You could do a 4th next. You could do a 3rd next. Actually, I'm going to focus on thirds today. So it's really chicken and egg. So that second fail, trying to make it as linear and sequential as possible, is also not how kids are going to get deep learning or fraction. The answer to that, the solution to that, which we'll focus on more today, is we need to teach how the brain learns. And one of the cognitive science strategies is called interleaving. Interleaving. Nicole, I just saw your comment. Are you making a confession? Type A habitual textbook follower. I know you. I know you. Good job, girl. Good job. The first step is admitting you have a problem. I know Nicole. Nicole's a frequent flyer, so I'm allowed to say those things to Nicole. See, now I have so much swirling in my head now. I'm like, what was I just talking about? No, solution to see, okay, cognitive science, interleaving. Interleaving is about learning things, multiple things, by switch tasking out of context, jumping from one thing to another. However, identifying a few things, not a lot of things, and focusing for a little bit of time and then switching to something else. That's called interleaving in cognitive science. That is actually how we increase memory and long-term learning. Now, think about how math textbooks are set up. That's not even a thing in math teaching. So, like, we are so working against the brain when we're teaching math. Like, we're doing all the wrong things. And guess what? We're busting our butt at it. Like, we're working so hard at it and wondering why we're not getting results because we're doing the exact opposite of what we should be doing. But we don't know any better. That's how we were taught. And for some of us, we're going to say, that's how I was taught and I learned it just fine. Yeah, wait till I ask you some of the questions we're going to do today. Some of you are like, yeah, I never got it. Gosh, if I would have learned it this way, maybe I would have understood it. So we really just have to open our minds today and think, okay, how do I need to change? So that second thing with teaching linear sequential, the fix for that is teaching in chunks, interleaving, throwing in a fraction on a Thursday out of context from what you're currently teaching just for the heck of it, and setting a timer for 8 minutes and having conversation for 8 minutes and then moving on to something else that's totally unrelated. Now, in that 8 minutes, you're going to get very distraught as a teacher. You're going to start to reveal actually how much they don't know. And it's going to scare you. And you're going to be like, I'm never doing that again. Guess what? They already didn't know it. You just found out more of what they didn't know. So you're just exposing it more. But by exposing it, then you know you can teach lessons and set up lessons and design experiences later for them to figure out and reverse their misconceptions. So yeah, you're going to find out so much more about what they don't know. And it's funny because I talk to teachers all the time and they're like, today's kids are just so much worse than what they know so much less. No, because we've really grown in our instructional strategies over the last 20 years, we've done formative assessment, understanding by design, start with the end, balanced assessment. All these initiatives have come and gone, and we actually have improved a lot of our instructional facilitation, which means we've exposed a lot more of the innate intuitive understandings and misunderstandings that kids have. So because we're actually doing better, we're exposing more of what they don't know. It's not that today they don't know more. It's not that today they know less. We've just gotten better at exposing all the deficits. And just kind of chew on that. Think about that for a moment. So yeah, the number 2 fail is linear sequential. So today I'm going to give you lots of chunks and some things that you can take back and use this week in your classroom and just see what kids do. The third fail, and this is going to be highly controversial. I'm not even going to write that anywhere because I can't even say it, let alone spell it. So one of the big fails in students learning fraction deeply is using circles as the foundational tool. Circles are the most complex shape. Think about unit circle. Some of you probably never made it far enough in high school math to see unit circle. But the reason that we study circles in like way, way later advanced math is circles are the most complex shape to analyze. Another complex shape to analyze are triangles. Triangles, less complex than circles, but still very complex. Oftentimes, there's an entire course dedicated to triangles. It's called trigonometry. And then the simplest, least complex shape, which is what we should be using to ground fractions, is the rectangle. So I gave you 3 issues here, but let's look at a little bit of the fixes for each one. Number 1, few exposures. So the fix to that is multiple exposures. So I would say I challenge you to go back to your classrooms and do 8 minutes a day for 2 days a week from now until winter break. 8 minutes a day, 2 days a week on something I'm going to share with you today. Don't go back and start your fraction unit and only look at fractions for the next 2 weeks. That's not what I'm saying, because then that's not interleaving. Then you're getting fewer exposures to other things. You see, something always has to take the back seat unless you do interleaving. So the first fix, go back, expose your kids, especially in kindergarten, 2 days a week, 8 minutes a class. Now you might be like, John Lee, can I do more than that? Yeah. Just don't do a 2-week unit and only go back and do fractions now. Because you're like, you know what? I need to make up for all those lack of exposures and fractions. So I'm going to expose them for 42 minutes a day for the next 15 days. No, that's not the solution either. The second one, deliver in chunks, because the second fail was that whole linear sequential. So the fix for that is deliver in chunks randomly using a stimulus approach. And this is the first example that we're going to look at. Using a stimulus approach. So this that you see on my screen, 2/3 equals 4, is a stimulus approach. Now, it's symbolic, it's symbols, but I'm using it as a stimulus, so I'm not asking kids to solve anything. So the definition of a stimulus is something that's going to stimulate mathematical thinking, reasoning, and sense-making. A stimulus is going to allow and promote thinking, reasoning, and sense-making. A stimulus can be a picture, a symbol, an equation, a video, a situation, a story. It could be anything that removes a lot of the noise, not the noise we hear, but the noise that distracts kids from making sense. So noise is like words. Noise is like questions and prompts that promote answer getting and solving. We've got to remove all that, remove all the noise, remove anything that's going to promote answer getting and solving. Believe me, your kids are going to try answer getting and solving naturally because they're so trained for it that you can't overdo the non-answer getting, non-solving. So you want to show them a stimulus. I've chosen this one. We're going to see a few of them today. Removing all the noise for the potential of thinking, reasoning, and sense making, and eliminating answer getting and solving at first. That's a stimulus. Believe me, you have stimulus in every textbook lesson. So when Nicole goes back after these Saturdays, she a lot of times goes back and she's like, you know what? I'm going to teach this lesson in the textbook that I always teach, but I'm going to pull this little piece as my stimulus. The way that I do it is I take a picture with my phone and then I crop it to just the piece of it without all the noise, and then I show it. I'll show you a couple examples of that today. But that is the fix for number 2, trying to do this linear, streamlined approach. And we're just messing it up because that's not how the brains even think about numbers or think about anything for that matter. So you just want to pull something randomly, put it up there. And then what do you do? Is it like, what do you say as a teacher? Because it's like, okay, there it is. But like the teacher's looking at this, the kids are looking at this, and they're like, what are we doing? Like, that's ludicrous. Like, I don't even agree with that. What are we doing? So what we say is my favorite 3 words. Tell me about. So what I want you all to do in the chat right now is tell me about this equation. 2/3 equals 4. Tell me about what you see. Tell me about 2/3 equals 4. Now, if anyone would like to unmute and talk to me, I love the interactions. Who's got something to say? Ha ha! Some of you don't even know what to write, do you? It's okay. See, because even as middle school and high school teachers, upper elementary teachers, we ourselves don't even understand what this could mean. We don't even have a deep understanding of fraction. Many of us that do fraction well and think we have a deep understanding of fraction, we can do fraction. We can solve fraction problems all day long and get the correct answers all day long. That does not mean we understand fraction. Ah, beautiful. Look at you guys. I love it. Some of you are like, I got nothing. Some of you that do know fractions pretty well, you know a context that this will work. Yeah, good, good, good. Read each other's comments here. I don't need to repeat them. You can read each other's comments here. They're really good. You guys are saying things better than I would. So I guess I probably could have said, when, oh, Linda. Linda. Oh, take a look what Linda wrote. That's good. Oh, you guys are so good now. See what happens when we just like here's what a stimulus does for our kids. This is the power of a stimulus. And this is a power of promoting thinking, reasoning, and sense making, and trying to eliminate out of the gate solving and answer getting. This is what's powerful about this. At first, when our kids haven't really done this before, they're like, they're awkward, they're icky, they're like, what? Like, what do you want me to do? And it's like really awkward for the teacher too. So then we're like, this doesn't work. This is dumb. Who's that John Lee girl? I'm never going back to her Saturday. But once we give it some time, what this actually does is it levels the playing field in our classrooms. Because we show something, and I'm not asking kids to solve or get an answer at all. So like when we typically give like a solving and answer getting, which is 98% of what we typically do, we have the kids who can and the kids who can't, and then a whole level of in between. So we're always reminding these kids they can, and we're always reminding these kids they can't. And then we're reminding these kids, hey, I'm somewhere in the middle, but at least I'm not the lowest. That's what we're saying to our kids every day when we have them solve and answer get. And think about when those kids walk into 8th grade, the amount of baggage they have from that. No wonder they despise math and despise every math teacher. No wonder. We have told them every single day, multiple times a day, this is where you are. You're at the bottom. And guess what? I'll give you a new problem tomorrow, but you'll be at the bottom again. Because the stimulus that we give are answer getting and solving most often. But if we use a stimulus in our definition to promote thinking, reasoning, and sense making, we show something without the noise and just say, tell me about. And then look, see, I didn't jump in with my opinion. Do you see this? You have to let it go. You have to let it go. I have to let it go. I cannot pretend that I'm always the expert in the room because I'm not. Actually, a lot of these kids know more than I do conceptually. So, I mean, let's just be humble for a moment. So using a stimulus this way to promote thinking, reasoning, and sense making, and just say, tell me about, and just let kids say stuff. I might write what some of these kids say. Like you guys can all see it because it's in the chat, but I might write what some of these kids say. And the way that I'm going to respond, I'm not going to be like, correct. No, that's incorrect. The way that I'm going to respond to any of their thoughts, any of their perspectives, because I'm trying to extract as much of their perspective as possible, the way that I'm going to respond, whether they're correct or incorrect, is that especially if a student is incorrect in their thinking, one of the ways I like to respond is, that is brilliant. Because I didn't say, that is accurate. I said, that is brilliant. That is brilliant thinking. Your thinking and perspective is absolutely brilliant. Why? Because 60% of the adult population also think that. I mean, I'm probably not going to say that to the kids, but like, that's why it's brilliant. Because I can use that. That's substance. And then one of these kids that's like, well, yeah, but you're talking about 2/3 as groups and blah, blah, blah. And you're like, okay, fancy pants. I'm going to let that kid talk and I'm going to be like, ooh, that's interesting. And then that kid's going to freak out. But that's what I want them to do. I need these kids to freak out sometimes and be like, well, I know that's right. Hey, calm down, buddy. I didn't say whether it was right or wrong. I said, that's really interesting. And then I might ask the rest of the class, why do I think that's interesting? And then they'll be like, was Sam wrong? I'm like, it's interesting. Why? Do you see, you're changing the mindset and the climate and the culture. We talk about fixed and growth mindset all the time, and then we teach it in a fixed way. We teach it procedurally. We're like, hey guys, today we're going to have a lesson on growth and fixed mindset. And you shouldn't have fixed and you should have growth. And here's the definition. So boom, now everybody has growth mindset. Yes, I'm making fun of it because it's dumb the way we present it. I've engaged all of you for almost 45 minutes. And my goal was to get to this point and say, how do we create a climate and culture for growth mindset? I didn't start off that way. And this is why when teachers and admins say to me, Well, what standard are you teaching today? You have to post it first. Well, then we're getting the punchline. Do you see what I mean? Like, gosh, we're doing it all wrong. I'm getting ugly now. Okay, calm down, Johnny. All right, talk to me. Unmute. Who's got something to say? I'm checking the chat here. Who's got something to say?
So I always end up going back to my textbook. I am such a creature of habit. You know that.
Okay, girl.
But I will say that I did start off this school year until I got sucked into the textbook. I did start off with doing the stimulus, and we did it once a week. And so what I did was I told everybody, I did the tell me about what do you see, what do you notice. I gave them a post-it note and I told them to write it down, and they were to post it on to the chart paper that I wrote it on.
Awesome.
So then I took it and I set it aside. We did our, week thing, next Monday, did the same thing, came back with more advanced on what, because I think the stimuli that we had in September was the
diagonal line.
The diagonal line.
Cool.
And I put it in the concept of the chart paper or the grids. Yeah. And so then did the same thing and did that's interesting that, one person on the very first stimulus said it was a stick. I said, yeah,
fantastic.
Yeah. So I started doing that and then I got away from it. So I like the idea of going in and doing 8 minutes twice a week. I'm going to do it. And I do want to mention, how we do the folding paper, and I don't want to veer off track.
No, please do.
Well, so the folding paper, I came across someone was getting rid of calculator paper, the tape paper, the rolls.
Yes.
I got a whole bunch of them. I'm like, I've got to tell Jenna Lee this. I don't know if she's ever mentioned that, but yeah, so it's automatic paper folding paper for you. So if anybody can get their hands on it.
Look for this. They are in school buildings everywhere. Nicole, you make a really good point. It's the like cash register tape, like the
yeah, it's just in rolls, and it's automatic rectangles. You just cut it off, because I'm like, I'm wasting all this copy. Not wasting.
No, I know.
I'm using a lot of copy paper to do this, and so I'm like, this is perfect. So I just was like, I think that's what you're gonna probably get into is paper folding today. So I was like, I'll mention it today.
No, I love it. You know what? And it's funny because if you are brand new here, obviously you're getting something out of this, even if it's frustration. But if you are not new here, what you start to do as you have more and more interactions with us, as you start to come frequently on Saturdays, is you then start to connect everything that we're doing. So today, like if this is the first interaction you've had with us, today you're going to be like, this girl back crap crazy. Like, how does she put all this? Like, what? This is changing everything I do. It's not really it sounds radical at first until you see the big picture, and you won't see that by the end of today. So what I love about what Nicole is saying are the connections and associations that she's making. I'm going to go back to the textbook one. Remember I talked about season 2, October to December. This is exactly when we fall into the textbook trap, because we just need our sanity. We just need to be sane. We need to it just needs to be easy right now. So we fall into our textbook trap, which is totally fine. We deserve it. We deserve to have simple planning for a few months. We deserve it. That's why we go really intense in January and come back to like the whole foundation of this model. But right now we get into our textbook trap. That's why I'm asking you 8 minutes a day, twice a week, blah, 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 give a stimulus. And then, yeah, Nicole, great examples. Absolutely fantastic. Okay. So now here we go. Let's do this. Let me go back to, okay. So here's my stimulus. Now, at Minds on Math, we teach all standards, preschool through high school, with what we call the Dirty Dozen. There are 12 tasks. They're the same. They're not different per grade level. They're the same 12 tasks from kindergarten through high school, just like we have mathematical practice standards. These aren't mine. These are documented mathematical practice standards. There are 8 of them. There are 8 mathematical practices. This is half of what we should teach. Half of what we teach are our content standards. The other half of what we teach are mathematical practices. And this is kind of the, like, I don't want to compare it to the procedural conceptual, but just for simplicity, half of what we teach are our content standards, half of what we teach should be mathematical practices. There are 8 mathematical practices, but they are exactly the same, word for word, K through 12. So our Dirty Dozen tasks are exactly the same, K through 12. And we can teach almost every single standard within these 12 tasks. That's it. All you need are 12 of them. One of them Nicole mentioned is paper folding. So if kids have had experience with paper folding before this stimulus, 2/3 equals 4, they're going to use this as a, because Nicole's like, I think you're probably going to do paper folding because that would only make sense with this stimulus. And she's exactly right. Because anytime my kids see a fraction, they think 120 chart, paper folding, paint problem, candy problem. Like these Dirty Dozen tasks, we call them reference tasks. Because in the first season of math, we introduce all 12 reference tasks. Now, some of my school districts, they're like, John Lee, we can't handle all 12. Can we just do 4 of them? Yes, great. I'll tell you which 4. So we expose as many of these reference tasks in season 1 as possible. That way, when we get into our textbook, October, December, we now have all of the reference tasks that we've introduced at the beginning of the school year to now use to support our instruction of the lessons in our textbook. And that's really the goal. And I saw someone had put in the comment, where does the rubber meet the road? What happens is when we combine the reference tasks or the conceptual experience to the procedural. So for example, I can't just represent fraction all the time with these words. However, when I represent it with these words, I give more access to more of my students. So they're like, oh, I know what you mean by 1/8. It was on the paper folding when we made 8 parts. And because it's not in this symbolic form, our most struggling kids have more access to it. And then along the way, I'm always like, okay, and then remember 1/8 can be written like this. Ah, but guess what? 1/8 can also be written like this. Then we start to really formalize all of this conceptual experience, but it's always a toggle back and forth. It's always a toggle. It's not like we do all the conceptual first and then no, it's a constant toggle back and forth, conceptual, procedural, conceptual, procedural, conceptual, procedural. But with reference task, we have that extra element of contextual and experiential. I'll show you what I mean by this in a moment, but let's look at the stimulus. 2/3 equals 4. Now, if any of you know paper folding, there are 3 colors we deal with. The white paper strip, we iterate halves. Iterate means the same action over and over again. I will tell you the word iterate is in first grade standards. If you look at the critical focus areas, the exact word iterate is in first grade standards. See, a lot of times people come to these and they're like, Jonalee, you're telling me to teach a whole bunch of things that are not my standards. No, on the flip side, I don't think you've read your standards, including the critical focus areas and the mathematical practices. The standards are much more than one MD3. Like if that's all you're teaching, you're only teaching part of the standards. So kind of reflect on that for a moment. But the white piece of paper, we iterate halves. We fold in half, 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 half. Okay. Kids have explored that because paper folding is one of our reference tasks. The yellow piece of paper is thirds. So what oftentimes happens if we're making thirds, let me unshare because I'm little for you right now. Let me be big girl right here. Okay. So I let kids play with the yellow to try to make 3 equal parts. And the one thing they typically do is this. They touch the edges together and they're really careful to get those 2 pieces the same size. Okay. And then they make a crease and they open it up and they're like, I've got 3 pieces. Ooh, they're not equal, but I think I have thirds. And then I'm like, you don't have thirds. You don't have thirds. See, I'm not going to say that's interesting and that's brilliant. I'm going to say you don't have thirds. Okay. So see, we have to toggle between these conceptual and procedural experiences. So I'm going to say you don't have thirds. And the reason you don't have thirds is your 3 parts aren't equal. But instead of having them try again, here's the next prompt I do. What fraction did you create? They have no idea. They have no idea. Well, let's take this as your piece. And sometimes what I'll have them do is cut out from another paper strip this piece and then use it as the measuring tool here. So how many of this size piece fits? Oh, shoot. 2 of those fit here. So like technically there's like a crease here that's hidden. So what I do is I have kids explore this and they're like, gosh, I made fourths. So this technique is really brilliant actually, but it doesn't make thirds. It actually makes fourths. And that in and of itself is a fantastic conceptual experience. Like if that's all your kids do and you're like, okay, forget about the thirds today because that's a win, move on. So that's what typically happens. And I wanted to share that because I want you to know what to do when you don't know what to do when kids do that. And that's a really important lesson. And then interleaving says you go away from this because another cognitive science strategy is spaced repetition. We want repetition, but with space of other out of context stuff in between. So then let's say 3 weeks later, we come back to the yellow paper strip and I'm like, okay, guys, you're all going to get a new yellow paper strip. Tell me about what we did before. And they're like, oh, we did that. We were trying to fold thirds and then we did that thing and blah, blah. I'm like, great. So I'm going to give them their yellow paper strip. And I'm going to be like, okay, make 3 equal parts. And they're going to put those edges together and they're going to crease it. And they're going to be like, oh, freak, I remember this happened the last time, but you told us it wasn't thirds. And then I will say to them, what did I ask you after that? See, this is metacognitive feedback. This is another cognitive science strategy where we get kids to think about their thinking, where they can teach themselves and discover it themselves. And I am merely the facilitator of questions and prompts. So I'll be like, what did I say about that? What did I ask you once you did, they were like you, and then some of them will remember, well, you said, well, what fraction is it? Now, some of them will be like, I forget what you asked me. And I'll be like, good. Forgetting is necessary. We should celebrate forgetting because in this model, the same things come back over and over and over 5 or 6 times a year. And then every single year in our schools, that kids are going to get so much interaction with paper folding that when we come back and ask them to retrieve, which is another brain-based strategy, retrieval practice, forgetting is necessary for long-term learning. So I tell kids, the more we forget, the more we should celebrate, but we can't stop there. Then we have to go into the act of remembering. So what I'm going to say is, let's celebrate forgetting, but let's deepen the neural pathways in our brain and try to remember. Does anybody remember what I asked you when we folded this and got these things that weren't thirds? And if nobody remembers, that's okay. I'll remind them. But there's always a student that says, oh, no, you asked us what fraction it did create. And then another kid was like, oh yeah, and we cut that end, we cut that piece. And then, oh my gosh, that's right, it created force. See, I need to get them to discover it instead of me reminding them. Every time we as the teacher and facilitator remind them by telling them, we're lessening the long-term learning results. But if I can facilitate with prompts and questions to get them to say it and them to retrieve it and them to discover what we did before or hear it from another student, I'm deepening the neural pathways in the brain. I'm gaining depth of knowledge. I'm getting kids into deep thinking and long-term learning. So really, the question is, how? How do I do this, Jonalee? Well, let's step back for a moment. Let's step back for a moment and analyze that. Think about the last hour you've been on here. What are some of the hows that I presented, but maybe I didn't explicitly say? See, this is what happens when you come to a session like this or you come to a professional development. You're like really stimulated and engaged. And for some people, they're stimulated, engaged because they're enraged, because they're like, you freaky, but I can't leave because I got to watch this train wreck. Or you're really stimulated, engaged because you're like, this actually makes sense. And what else do I not know? Like it, and then you're like, okay, I really liked those things she did. Then you go back and try to do it. And then you're like, I don't even know how to replicate this. So see, the implementation doesn't happen. So what doesn't happen in sessions like this is the metacognition, is the deep thinking about what was just done to me. So let's analyze that for a moment. What are the big hows? What have I presented to you today? Or how have I presented it that has stimulated your thinking? Type in the chat or please unmute, talk to me. You're speechless. Oh, shoot, Troy, I think you're trying to talk, but I just hear fuzzies. Shoot. Keep trying. Keep trying.
Go back in the settings and see if your mic is attached, Troy.
Oh, I see down where the mute is and the arrow and the, make sure the mic is same as system. But anyway, type in the chat some of these nuggets. Like what were some of the things that I didn't like explicitly teach you and that you may have missed because it happened to you, but it wasn't like my agenda to explicitly teach you. So just type some of those nuggets in the chat. And one of the things is I jump around a lot. And I've had to learn to get good at that. I know. Nicole's like, come on, John Lee, just get into this 2/3 = 4 because I'm going to hurt you.
Jonalee.
Yes, Teresa, talk to us.
Well, you know how you were mentioning the interleaving and going back and forth. Now, I'm working on I'm trying to do a workshop for my OTs having to do with spatial reasoning and spatial relations and math, because, you know, I have to do something for them. But one of the things when you mentioned the interleaving, a lot of times what we do as OTs, like I fly a lot of times by the seat of my pants only because I know my kids so well, like you know your kids. And I feel like I do that a lot. Like one day I feel like, oh, my kids are going to do like because I have my goals. So my goals aren't all consistent with one topic. So I'll say, okay, today we're going to do writing, and tomorrow we're going to do visual perception, and the next day we're going to do cutting. So in a way, I am doing interleaving. I'm doing one topic today, and maybe tomorrow I'm not doing the same topic. And then like I'll come back to doing something that they liked and in a couple of weeks. So then I bring back a thing and I'm going back and forth. So when you said interleaving, I'm like, I do that
You
because
described it perfectly.
I'm going back and forth and I'm bringing back things, and Johnny couldn't cut the other day, and like this past week we were doing a cutting lesson, and I said, remember the other day you were having a struggle with that? Today we're not going to do that. You're going to listen and you're going to watch me, and I'm going to go, and I become more explicit when I go over it with them so that they can actually. But that's the whole thing when you said interleaving, and I and everybody may not be doing it, and maybe they're doing it in ELA, maybe they're doing it, you know, or whatever, but we all kind of do it, but maybe we don't see that we do it. So
Great.
Can I
mean?
add a point there, Teresa?
Go right ahead.
Occupational therapists do not understand and know that concept exists. So that is perfect for that thing that you're doing.
Yeah, that is a great point. And actually, for the math educator, a lot of times we think spiraling is interleaving. Spiraling is different because spiraling is not intentional. The power of interleaving is when it's intentional, like Teresa described. She knows, let's say she has 3 goals on a kid's plan, and she knows she's going to do a mix of those all of the time. That's true interleaving. You described it perfectly. Other thoughts, comments, questions? Oh, I got it. Troy, I got your. Yes. Yes. Other thoughts, comments, questions?
I will say that I'd like to do the square pizza that you give with the making rectangles and stuff. But it was funny because we had a pizza party and the box came in a square box, and I was like, "Oh, guys, our square pizza problem!" And when I opened it up, it was round. And one of the kids was like, "They're losing a lot of area on those edges." I was like, "Yes."
That's awesome. So for those of you that don't know, one of our Dirty Dozen 12 reference tasks is called the pizza problem. And the gist is a pizza company makes square pizzas. And so we do this problem again in kindergarten through high school, but then we up level it every time we do it. And so that is really cool, Janet. And you teach 7th grade. So how cool to look at that perspective of it. Very cool. Anything else? Now, these Saturday maths, the intention is to really disrupt, So if we really want to scale math achievement, we kind of have to start over and rethink everything that's been done to us and that we're doing to kids. And I always say that it's an 8 to 10 year process for any individual teacher to really reshape this mindset. So coming to Saturday math, you always get like the tip of the iceberg, like just enough to make it gritty for you. And then what we say, how kids learn and how we as adults learn, is called interactions over time. And that's our phrase for the interleaving concept. So what we do in our model is we define our most essential chunks. Maybe our most essential chunks are equations, factors, graphing on the coordinate plane, fractions. I mean, I don't know, maybe you have 8 essential chunks of your content. If those 8 things are so essential, they cannot be taught in order because there's always going to be something that we're not going to get as many interactions for. And we learn based on interactions over time. We as adults, when you come to Saturday Math once a month, you'll learn a little more each month. It's called interactions over time. That's the best way to learn. But you don't get all the learning at the first sitting. You see, so that's a little uncomfortable. It's a little counterintuitive. We want to teach our students the same way. In that first season of math, we want to expose them to all of our 8 essential chunks, whatever you've defined those to be. And then in the second season, October through December, when we're trying, take Nicole's advice, get your sanity, go back to your textbook, but don't forget about those 8 essential chunks. And twice a week for 8 minutes, bring in as a stimulus each of those 8 essential chunks. See, you can't make everything important and then order the way it's taught. Whatever's important needs to come in as a stimulus all the time. Even if it's for 8 minutes, 6 minutes, that's it. Just to give kids another interaction and exposure. Our gifted kids need 1 to 2 interactions with the same thing before they have forever learning. Our bright kids, whose parents think they're gifted, they still need like 5 to 7 interactions before they have forever learning. Our most struggling kids need 40 to 100 to 200 to maybe 400 interactions with the same thing before they know it forever. And the question is, how do we get more interactions for our kids over time? Well, what we do is we define our essentials. For us, we have the Dirty Dozen reference tasks. We actually have 3 essential concepts, K-12, fraction, factors, and function. Our entire model is built around those 3 things, fraction, factors, and function. And what some of my second grade teachers say is, yeah, but we don't teach function at second grade. We don't teach factors. I'm like, you do. See, this is where we're lacking math knowledge. If you look at second grade standards, fraction, factors, and function are actually hidden in all of the standards because function is really about rate. And the bottom line, it's all about skip counting. That's it. That's it. It's skip counting. But see, we don't relate it that way. So we think, oh, we can't study function until the standards say so at 8th grade. Well, how do we expect kids to be exposed to function for the first time at 8th grade and master it? They haven't had exposures to it since kindergarten. But think about if kids had exposures to function, rate, just skip counting, skip count, that's it, since kindergarten. But we're always relating it to this path of function. And that's what our model does. Now, I'm describing it very poorly today because there's so much that goes into it. I'm just giving you nuggets. But let's go back here. Let's go back to this crazy thing. Now, at the third interaction of paper folding, no, let's not, because I need a big screen. I was going to do this before and I forgot because I got sidetracked. And okay, here we go. So at maybe the third interaction of paper folding, I will then explicitly and deliberately teach kids verbatim how to get thirds. So now they're just going to mimic me right now. They're all going to get a brand new yellow paper strip. And I'm going to say, don't make a crease until I tell you to. Like, you're following me today. This is a project on following directions. Today, right now, I don't care what you think. I just need you to do what I say. Okay? So, remember when all y'all wanted to fold this in and touch those edges? Stop it. Unless you want to make fourths, then go for it. Okay, so we fold the edges in, we touch them, but then we have to overlap. So do this with me, and then we start over. A lot of kids don't have, see, we have a couple occupational therapists here, Sherry and Teresa. They're from the medical world, they're occupational therapists. They actually, when we do Impact Wednesday, when we do Impact Wednesdays, I don't even have the registration up. Oh my gosh, I am horrible. I'll email you guys the link. But we do another free session every month called Impact Wednesday. It's coming up this Wednesday. I promise you I will send you guys the link. If I don't, email me and be like, give me the link to register for Impact Wednesday. But when we do Impact Wednesday, it's an extension of Saturday Math. So what I believe that Sherry and Teresa are going to talk to us about on Impact Wednesday is the issues that kids are going to have with fine motor and doing the paper folding. So, we're like, there's so many other things other than mathematics that get in the way of students having access to this, but that's for a Wednesday. But anyway, so I say to kids, okay, start over, touch those ends together, but overlap. And kids' fingers are going to have a hard time. High school 10th graders have a hard time if they are in like a resource math in high school, or if they're in like a struggling math class in high school or whatever, they're going to have struggles folding paper because all of this is connected. So anyway, you're going to have your first graders struggling, and they need to struggle with it because we're going to do it again and again. Do not take their paper strip away from them and fold it for them. You will hear my voice in the back of your mind saying to you, stop touching their paper strip. Stop saving them. This is not a hot stove and it's not a busy street. They're going to be okay. Okay? So we cross it, we overlap. And then we have these 3 layers. So if you look at it sideways, we have these 3 layers. And what I tell kids is you have to shimmy this. You got to shimmy it so that each of the layers are as close to equal size as possible. Now, once you can show me that, I will give you the go ahead to make your crease. So then you make your crease. And then we have thirds. Okay. Now, my friends. Oh, I know. Now some of you are private messaging me that you gotta. Oh, did I put the registration up for Impact Wednesday?
I did.
But did I do it in Eventbrite? I thought I forgot to do it.
I don't know. That just goes to your homepage.
Oh, okay. I think I forgot to put the registration up this month. I did because I have no more events scheduled. Shoot. Yeah, do that. Go to my homepage, follow me. As soon as I put the registration up, the link, you'll get an email from Eventbrite, but I'll also email you the link. I can't believe I forgot to do that. Yes, Krista, Friday, 8 a.m. Norton. Yep. Yes, please. You are awesome. Sorry, side note. Okay, so let's share our screen for a moment. That's not what I want. Oh, you want that. The success path for this math model. You're not getting it yet. Okay. So what we also try to do is have kids toggle between physical hands-on paper strips and the bar model. So we've got the yellow paper strip and we've got these 3 somewhat equal parts other than my little hump there on the left, but whatever. Okay. So what's this stimulus? What does this mean on our paper folding? Because Nicole said a while ago, I think you're probably going to do paper folding today. Well, yes, because Nicole is grounded in this model in these reference tasks. So when she sees a stimulus, automatically her and many others are connecting it to one of the dirty dozen. Any math that you see, if I give you an equation, one of my favorite equations is 2/3 x plus 12 equals -6 plus 3/4 x. And if I said, ooh, what reference task could we reference for this? My fourth graders, I mean, even though like fourth graders aren't going to be solving this for X, of course we do, but we don't do it in the traditional way. My fourth graders will look at this and be like, oh, that's a Jesse and Kay. It's a Jesse and Kay. And I'll be like, okay, so if this is Jesse's money, tell me about it. And they're like, Jesse starts with $12 and gets 2/3 of a dollar every day. Like, that's what third and fourth graders can tell me. Oh, that should be a 2. You guys know what I'm talking about. Okay. And then if I'm like, okay, well then tell me about K. Okay, so if this is K's money, K starts owing $6, but gets 75 cents every day. And that's all we do with it. That's all we do with it. Who starts with more money? Jesse does. Because Jesse starts with $12 and Kay starts owing money. So Jesse starts with $12. The question is, will Jesse always have more than Kay? Well, you have to look at how they're gaining money. And in most cases, in our Jesse and Kay scenarios, my students say, well, typically Kay is going to pass over. So at some point, they're going to have the same amount of money. And we want to figure out what that is, but we may never figure out exactly what it is. But let's see how close we can get. You know what, guys? Today, all we're going to do is start at 12 and we're going to skip count by 2/3. Guess what? We're doing rate, which is going to lead us to function. And we're skip counting by 2/3, which is good fraction, conceptual, contextual, experiential learning. So that was an aside. See, I'm such a rabbit hole. I actually have a pet rabbit. So it's only fitting that I'm constantly going down the rabbit hole. His name is Loki. He's so cute. I'll show you guys one Saturday. So 2/3 is 4. So here we have 1/3. If this is 0, and if this is 1 for 1, this doesn't always have to be 1 for 1 paper strip. And this is 2/3. Okay, so we've got that set up. And probably right now you're like, yeah, okay, Johnny. But we have to make the 4 where the 2/3 is. They have to be in the same spot on my double number line. Okay. So now, tell me about this new stimulus. Tell me about this new one. Unmute or put in the chat. Talk to me about this picture. Tell me about, see, we're always going back to having kids tell us. Have kids tell us. Tell me about this picture. Come on now. Put in the chat or unmute. Tell me about this picture. And this will be the last thing we do. Look, we only did 1 stimulus today. You'll have to come back next month for some more. Oh, good. Chat popped up. What do we got here? Oh, beautiful. Beautiful. Oh, yes. But see, you said that before, Troy. That was your initial gut. Because, I mean, obviously, Troy, you have a good fraction sense because that's what you thought of initially. And our kids don't. See, our kid, so we want our kids so badly to think like us that we want to project our perspective on them as much as possible. But we just need to shift and we need to shift and be like, okay, I need for my kids to think like me. How do I get them there? And that's kind of the beauty of this model. Beautiful, beautiful. Yes. And this is really cool because Nicole earlier on What did Nicole say earlier on? Because I know Nicole had something. Nicole said, I'm still thinking about, oh, this was her second comment. The 2/3 equal 4. And what is the true answer, which is what my kids will be doing while I let them wonder to keep thinking. Now, Nicole, in your comment, if you guys find the comment that Nicole put at 10:32 a.m., she said, I'm still thinking about the 2/3 equals 4. This was in the middle of us doing something else. See, she's still thinking. What I do a lot of times, the how, actually, this is right under the how. When I put the word how, I intentionally and deliberately let a lot of things linger. Now, this is going to be really uncomfortable and counterintuitive for a lot of you. I intentionally and deliberately let things linger. Here's the reason why. When we have things unresolved in our lives, our subconscious can't let it go. So we're doing kids a favor when we don't answer every single question. We need to leave some questions unanswered and some prompts unsolved. We need to let some things linger. And I've done a very good model of that today in a lot of ways. We need to let some things linger because our subconscious won't stop thinking about it, which is what we need to happen. The minute we confirm or deny students' answers in the classroom, all thinking stops and the subconscious quits working. But if we let things linger, the subconscious now is able to do what it's supposed to do for deep thinking and learning. And then, so kids are going to continue to think about this without even knowing they're thinking about it. So when we come back 2 weeks later for interaction 2 on the same thing, they will have deeply thought about this without even knowing it. When we sleep is really when our subconscious starts to work. So the more you let linger intentionally, don't let everything linger and then get messy, but intentionally let a couple things linger. When we sleep, when your students sleep, that's when the subconscious is really going to groove these lingering concepts. Then when we come back to it, kids are going to be ready for the up level. But before that, when I first gave the stimulus, I think Nicole said something, but maybe you didn't. Oh, I have no idea other than 2, 3, 4. That's what she said initially, which is beautiful. It's exactly how our kids think. So I want you to think about, and I'm going to give you this replay so that you can watch it a couple times to really go back and analyze what I've done to you today. Okay? So anyway, what I could do now in my classroom is I could say, perfect. If this one is 4, this one is going to be 2, this is going to be 6. I could confirm all of that. But notice what I did here. I'm like, talk to me. And you guys said everything that I needed to say in your comments. So see, I don't need to say it. So oftentimes what I will do is I will end the lesson. I'll be like, you know what, guys, thanks so much for coming today. This was Saturday math. And then you're like, but is 1 6? And we want to do that to our kids too. We want to be like, okay, guys, we're going to go ahead and stop that for today. I want you to go to this page in your textbook. And then kids are going to be like, well, wait a minute. You didn't put the number, like, is 1 6? And I'll be like, well, I don't know. What did Nicole say? What did Troy say? Janet, you said you thought of it like Nicole. Janet, tell us about that. You see, I always go back to the kids. And then I could have Troy and Nicole and Janet say things again as kids are getting into their textbook, but I still won't write it here. And then kids are going to be like, well, she didn't even answer our question. She didn't even help us. I'm helping you to help yourself. It shouldn't take me to solidify everything. Now, what'll happen is a week later, I might give this as a stimulus. A week later, I might give this. Actually, probably not a week later. Maybe after a few more interactions. I might give this. That might be my stimulus. And I might say, tell me about. And then what I might do is I might say, remember a long time ago when we talked about 2/3 equals 4? I want you to tell me about 2/3 equals 4 right here. Mind blowing. You probably didn't get what you came for today. So another way I can say that is you probably didn't get what you wanted today. But you need to trust me that you got what you needed. With that back crap crazy Jay-Z girl who just messed with me on a Saturday morning. All right, y'all. Our time's up. So what now? I don't know what.
See you at Impact Wednesday on Wednesday.
See you this Wednesday at Impact Wednesday. That I forgot to put the registration up in Eventbrite, but I will do that this weekend. I will email you all on Monday. I'll give you the registration link. Come to Impact Wednesday and we will talk about the medical, what words am I trying to use? The non-academic, thank you, Sherry, the non-academic portions of what we talked about today that hold kids back. So Sherry, my partner in crime here, is our expert in neuroscience and occupational therapy and sensory related processing, memory. Sherry, anything else you want to say that is going to give us a preview for Wednesday?
When we teach something, we learn it twice. Jim Quick.
So you're going to get a lot more of the neuroscience and the sensory and the medical reason of why our dyslexic, dysgraphic, dyscalculic, ADHD students struggle to learn. Thanks, Nicole. You're a doll. You're a doll. I love you guys. Love you guys so much. All right, we're going to go ahead and stop. It is 11 o'clock. We'll see you on Impact Wednesday and next month on Saturday Math. Bye, everybody. You're welcome. Hey, thanks. Thank you. And you are welcome. Awesome. Thanks for being here. Thanks to you newbies. Have a great weekend.